1.3, writing quadratic equations in vertex form. So if I give you a vertex and a point, you need to be able to write this equation in vertex form. So your objectives are, I can write quadratics given a vertex and a point, and then I can rewrite quadratic equations from vertex form into standard form. And so these are the two forms we're talking about. They're both on the formula chart. And remember, you will be provided a formula chart on the STAR test. You have a formula chart on your quizzes and tests also. And this is also in the course tools toolbox. If you click on formula chart, it's in there as well. And so these are both provided. This is your standard form, and this is your vertex form. You haven't seen vertex form yet. We're going to start learning it today. And so this is the vertex form, and I wanted you to note the three areas that are highlighted. Your A, and then you have an H and a K. And so these mean different things. And so let's talk about A first. A, which is the coefficient, it's a number out front. If it is a positive number, then it's going to open upward. That means the parabola is going to have a U shape. If it is a negative number, it's going to open downward, meaning the parabola is going to look like an upside down U. So that A tells you if it opens up or down. The H and K is your vertex. That's why they call it the vertex form, because you can see the vertex in this formula. And so it's going to be H and K. So the H is going to be the X value, and the K is going to be the Y value. All right, so now that makes sense that if H and K is the vertex of the parabola, then the axis of symmetry, remember, is always X equals the X value. It's going to be X equals whatever H is. And so it's going to be able to help you answer a lot of questions about these quadratics. All right, now we can use Desmos for some of this. I'm going to show you that in just a little bit, but for right now, let's just make sure we can identify parts of a vertex form. So in the first one, I gave you y equals 2 times x minus 1 squared plus 5. Let's concentrate on h and k first. And so the h in this one is going to be 1. Okay, remember that the formula is x minus whatever h is. And since it's x minus whatever h is 1. Okay, that minus right there is part of the formula. H is the actual number right here. And the k value is going to be 5. And so my vertex in this case would be the point 1, 5. Now, in this equation, y equals 3 times x plus 4 squared minus 6, the h value in this one is going to be negative 4. Now, we need to talk about why that's happening. Remember that the formula, this minus right here, is part of the formula. We're considering what h is. So here we just have x minus whatever h is, and it's just 1. So it becomes x minus 1. But here we have x minus whatever h is. And in this case, to become a positive, this had to be a negative 4, because a negative times a negative gives you that positive. And so a general rule of thumb is if you look inside the parentheses, if that is a minus 1 there, then you know your h is 1. It's the opposite. And if you have a positive 4 here, then you know that your h is going to be a negative 4, which is the opposite. Usually in algebra, with algebraic equations, if it's in the parentheses, general rule is that it's usually the opposite of what's inside the parentheses. It behaves in the opposite direction. All right, so now your k was negative 6. And so now it's important to notice that h value is subtracted, the k value is added. So the k, nothing changes. It's the same as what it says. But the h inside the parentheses is going to be the opposite. All right, so now let's look at the a. In this case, our a is a negative 3. Remember, it's the number that's out in front. You can see right here where a is. It's going to be negative 3. And since that is a negative number, it's going to open downward. All right, in this case, we have our a is 2. And so that is going to open upward. Like this one looks like a U. This one looks like an upside down U. We've been working on that for a little while. All right, so let's put this all together. And you can use Desmos for this, and I'm going to show you how to use Desmos in just a second. But for right now, I want you to see that you really don't have to put this in Desmos to answer these questions. If you know vertex form, the benefit is you can see the vertex, you can figure out the axis of symmetry, and you know which way it opens. And so let's start with the vertex. Remember, inside the parenthesis, the h value is going to be the opposite. So I know this is going to be a negative 7, negative 4. And if I know that the vertex is negative 7, negative 4, I know the axis of symmetry is going to be x equals the x value. So that's x equals negative 7. And then by looking at the a, it's a negative 2. That means it's going to open downward. Now, let me show you in Desmos what that looks like. And so I have gone through and put that equation in just like it says. I even put f of x. And when I did that, it graphed it. And so now I can see that the vertex, when I click on it, is negative 7, negative 4. Just exactly what we just said. And then the axis symmetry, I know is going to be x equals the x value of that vertex. And so I went in and typed in x equals a -7. When I did that, I can draw that line and show that axis of symmetry, splitting that parabola in half. And then obviously you can see now it opens downward. And so you see that it works. Okay, so I want you to try a couple of these. You can pause the video and try these two problems. Answer what is the vertex, axis symmetry, and which way it opens. You can use Desmos, or you can do it by just looking at the vertex form. And when you're done, unpause and come check your answer. Okay, go ahead and pause. Okay, so if you're back, then you would know that the vertex is going to be, in this case, the point 4, 1. And the axis of symmetry is going to be x equals the x value, which is x equals 4. And then this one's kind of tricky because I don't have a number out front. Like, what is my a if there's no number there? What have we done all year long when there's no coefficient? Well, it's understood to be a 1, and that's a positive 1. Otherwise, it would have a negative. And so since it's a positive 1, it opens upward. The next one, you should have got -3, 2 as your vertex. Remember, it's opposite inside the parenthesis. On the outside, it's the same. And then x equals the x value is x equals -3. That's my axis of symmetry. And then this one opens upward because 5 is a positive number. All right, so whether you just looked at it and did it, or you looked at it and checked in Desmos, or you went straight to Desmos, all three of those are acceptable things to do to answer these questions. Okay, so now the next part of this is converting from vertex form to standard form. Now, there's going to be quite a bit of solving in this, so if you need to take a small break, you're more than welcome to, and then come back and start the video again. Okay, so now let's talk about how to convert these. And so the first thing you're going to have to do, if you remember PEMDAS, right? PEMDAS states that you have to take care of parentheses and then exponents, and then multiply, divide left and right, and then add and subtract left and right. And so when I look at this, the first thing I see is I see a parentheses. But inside that parentheses, all I have is x and -1. And I can't do anything with that. Those don't go together. There's nothing to simplify inside the parentheses. And so I'm going to go to exponents. In exponents, I have an exponent right here, right? It's saying that the x -1 is being squared. If you remember from chapter 6, when we did the FOIL method and we did multiplying, then you know multiplying binomials, then you know that x -1 squared, you're going to expand that. You're going to write x -1 twice, okay? Once you expand that, the next step is to do the FOIL method, multiply these two parentheses together. And so I'm going to do x times x and get x squared, and then x times -1 and -1x. -1 times x is -1x, and then -1 times -1 is a positive 1. Okay, and then we combine those two middle terms, -1, -1's, and -2. Now, I went through that kind of quickly because we've already studied exponents, studied FOIL methods, studied multiplying binomials. And so if you're still struggling with this type of calculations, we need to be in tutorials and practicing getting that down, because it's not something that goes away. It's something you're going to have to know long term. So the sooner we get it down, the better. All right, the next step you're going to do is you're going to have to distribute that A, right? We can't add 3. We have to multiply first. And so that's the next step in PEMDAS, is multiplying. So I'm going to multiply that 2 into everybody. And I know that 2 times x squared is 2x squared. And 2 times a -2 is -4. And 2 times 1 is 2. Okay? And then the last thing that you would do is combine like terms. And you're always going to have the same two like terms, these two constants at the end, right? Because you had this guy being added at the end, this k value. And so we're going to have 2 plus 3, and that's going to give you 5. And so you can see that I started out in vertex form, and I am now in the standard form. Remember, it's ax squared plus bx plus c. So we're in the standard form of a quadratic equation. This little cheat sheet is in my graphic organizers. I'm going to work through this problem with you. And you don't have to have this graphic organizer, but if you want it, you could pause this video, go and print that out, or write it on your paper, and then have it kind of as a cheat sheet to help you remember what steps to do. But it's in there just in case you need it. And so the first step is going to be, you're going to expand the perfect square. Okay, so I'm going to do it while I'm working over here, right? So I'm going to do y equals, and I have 2 times x -1 squared plus 3. So I'm going to expand that x -1 squared. So I'm going to have y equals 2 times. Now I have x -1 times x -1 plus 3. Okay, the next step, you're going to multiply the two binomials. And so to do that, if you recall from chapter 6, we do the FOIL method. And so I'm going to do x times x and get x squared. Then I'm going to do x times negative 1 is my outside. That's negative 1x. Negative 1 times x is my inside. That's negative 1x. And then negative 1 times negative 1 is a positive 1. And then we can combine these two middles always. And so I get y is equal to 2 times x squared minus 2x plus 1 plus 3. Okay, and then now the next step is you're going to distribute the a into the parentheses. I'm going to change colors so it's a little easier to see. But you're going to have to multiply that 2 into all three terms. And so I'm going to get y is equal to 2x squared. 2 times negative 2 is a negative 4x. 2 times 1 is 2, and then plus 3. And then finally, the last thing you're going to do is combine those two like terms, those two endpoints. And so you're going to get y is equal to 2x squared minus 4x plus 5. And if you need to, you could put this in function notation, and it's going to be the same thing, right? It just has f of x out front. Okay, so that's a just kind of a little cheat sheet to help you remember what to do and when to do it. All right, now you can always use Desmos to check to make sure, and I'm going to show you how to do that. And so in Desmos, what I can do is I can go in. Let me give myself just a little bit of room here. I'm going to go in here, and I'm going to enter in this vertex form, just like it says. So f of x equals 2 times x minus 1 squared, and then it's plus 3. And then what I'm going to do now is I'm going to go down here and plug in my standard form, because these are equivalent equations. They don't look the same, but they are the same because they're equivalent. All right, so now when I put those in, what I can do now is find my graph, and I'm just going to click on this circle so I can't see the red. I'm only seeing the black graph, and you see the black graph there. When I click on the red, it's graphed right on top of it. So those are the same. If you make a mistake, let's say you do negative 5, they won't be the same. And so you could always go back in and plug those in and see if you were able to convert that correctly. Okay, good. Now, I want you to try this one on your own and see how far you get. Pause the video. When you come back, we will check. Mark, set, go. Pause the video. Okay, now that you're back, let's check it. So you should have expanded x plus 3 and x plus 3. You should have multiplied those two together. X times x gave you x squared. You have 3x and 3x, which is 6x, and 3 times 3 is 9. Should have distributed the negative 2. You would have got negative 2x squared minus 12x minus 18 plus 6, and then combine those like terms to get negative 12. Negative 18 plus 6 is a negative 12. Okay, we're not going to do this one because you're going to get plenty of practice doing this. All right, so now let's see. So this says it wants you to put it all together. I'm going to do one example of putting it all together. So once again, your vertex here is negative 5, negative 8. You can see it right there in your H and K. Your axis of symmetry is going to be x equals the x value. So x equals negative 5. And it's going to open downward because we have a negative, and that's understood to be a negative 1. Now, to go from vertex form to standard, first thing I'm going to do is expand x plus 5 and x plus 5. Then I'm going to multiply using FOIL method. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Combine your two middles. 5 and 5 gives you 10. Now we got to distribute this negative. Remember, that's understood to be a negative 1. So it's going to be negative x squared. And then negative times 10 is negative 10. And a negative times 25 is a negative 25. And I bring down the minus 8. And the last thing you do is combine these two terms. And so negative 25 and negative 8 is a negative 33. And then I could check to make sure I got it right by plugging in the vertex form in line 1 and plugging in the standard form in line 2 and making sure those two graphs match. Okay. This is on the PowerPoint. If you ever want, oh, no, I do need to do this one. So one of the things that they can do here is they could say, write the quadratic equation in vertex form, given the vertex and a point. Okay, now this is the part that's going to be new to you. It's going to be a little tricky because we're going to have to do some solving. And so now if they give you a vertex form and a point and ask you to write the equation, you have to decide, what do I know? Okay, and so here I have a y and I have an x. Well, that's a point, isn't it? Isn't having an x and a y, isn't that just a point value? Well, they gave me a point. And then I have an a, but they didn't really give that to me. And then I have an h and a k, and I know that's a vertex. And so I've color coordinated this so that you can kind of follow what's happening. And so I'm going to plug in what I know. In this form, I have 5 variables. I have a y, an x, an h, a k, and an a. Of those 5 variables, if they give me 4, I can find the 5th one. And they gave me 4. They gave me a vertex. That's my h and k. And they gave me an x and a y and a point. So what I'm going to do is I'm going to go up here and I'm going to say, okay, I'm going to label this. I'm going to say, okay, this is a vertex. That's my h and my k. And this is a point. So that's my x and my y. And then I'm going to go through and I'm going to plug those in. And so I know that my y value is 9. I don't know a. My x value is 4. My h is 5. My k is 2. So I'm able to plug in everything except for a. But I'm going to have to go find out what a is by solving. And so whenever I get ready to do this, remember PEMDAS, parentheses first. I have 4 minus 5. Well, that's a negative 1, isn't it? And now I have an exponent. So negative 1 squared is a positive 1. So now I have a times 1 plus 2. Now, people usually get tripped up on this part right here, but what you have to understand is this is 1a. It's multiply. You don't divide before you subtract. We got to get rid of this number first. It's a 2-step equation. So I'm going to subtract that 2 from both sides. And then in case you would divide by 1, but in this case, you won't have to divide by that number because you know that 1a equals 7 is just a equals 7. And so we know that the a is 7. Now I know the a and I know the vertex. I could go write that equation. And so y I leave open, x I leave open. I know a is 7, so I'm going to put that 7 in there. I know the h is 5, so I'm going to plug that in. I know the k is 2, so I'm going to plug that in. Now, this is not something that you're going to be able to do by just kind of watching. You're going to have to practice it. And so I'm going to throw another one up here, and I'm going to work this one with you also, and we'll kind of piece our way together. Now, the best way to study new things like this is to pause the video, try it on your own. If you get stuck, unpause the video and let that kind of guide you and help you all the way through the problem. And then go back to that problem at the start and try it again. And you want to keep trying that until you get those steps down. Learning math is 2 things. You have to understand how to do it and then not make simple mistakes. All right, so getting that how to is the critical part right now. All right, so once again, I'm going to go through here. I'm going to work this problem. And I know this is my vertex, so this is my h, and this is my k, and this is my point, and so this is my x, and this is my y. All right, so now I'm going to plug in what I know. I know that y is 1, right? Tell me right here. And I don't know a. I know x is negative 4. I know my h is a negative 2, right? Now remember, it's x minus a negative 2. And so what that looks like when you plug that in, remember, it gets tricky. It's the opposite. So it's going to be x minus, and then h is a negative 2, so that's a negative 2. Well, a negative and a negative turns to positive. And that's why Mr. Alexander put a plus 2 there. And then my k is a negative 3. And I'll bring it down. All right, so let's take care of what's in the parentheses first. Negative 4 plus 2 is a negative 2. Make sure you do the simple math right. You can type in negative 4 plus 2 on a line in Desmos, and it'll tell you what that solution is. So make sure you're using the calculator for your benefit. Negative 2 squared. Negative 2 times a negative 2 is a positive 4. Now we have a 2-step equation. I'm going to add 3 to both sides. I'm going to get 4a is equal to 4. And then we divide both sides by 4. And we find out that a is equal to 1. Now, we need to plug all that back in. And so I know that I'm going to have y equals a, which is 1. We don't have to necessarily put that there. Times x minus whatever h is. And remember, we talked about why that turned to a plus 2. And then minus k. And there's your vertex form. So the vertex in this case is going to be, they gave it to you, but you can also see it right here, negative 2, negative 3. The axis symmetry would be x equals a negative 2. Remember, it's the x value, x equals x value. And this is going to open upward because we found out that our a was a positive 1. Now, you could convert this to standard form from here. And in order to do that, in this case, we would expand the x plus 2. And then we're going to use FOIL method to multiply these out. X times x is x squared, 2x and 2x, and then 2 times 2 is 4. Combine your two middles to 4x. 2x and 2x is 4x. And then we don't have anything to distribute here, so we can just drop those parentheses. And now, or you could say, okay, I'm going to do 1 times x squared is x squared, 1 times 4x is 4x, 1 times 4 is 4. And then you're going to combine those last two. 4 minus 3 is 1. And now we have it in standard form. So on this one slide, we have every single thing that you learned today about vertex form. So once again, go back to the beginning of this, try it on your own. On this page, try it on your own. Unpause if you get stuck, check your answer, make sure you understand how to do it. And don't forget to go back in and throw this into Desmos and make sure you solve this standard form correctly. All right, so your next class, we'll have a quiz over this. Make sure you get this down. Tutorials are available if you need help. Usually I'll have several people that will sign in for tutorials on this lesson because of all the calculations. Make sure you complete your practice, your star checkout, and your ticket out the door. All right, have a great day. Come see me if you need help.